Let's talk about the converse of Pythagorean theorem. Let me explain exactly what that means and what that entails. We learned in an earlier video that Pythagorean theorem says that if I square the two legs, again, the legs are the sides that aren't the hypotenuse. So, like this would be one of my legs and this would be the other one. The hypotenuse is always that longest side. If we squared those two legs and added them together, then that would be equal to the square of the hypotenuse, this longest side right here. But this only worked if we had a right triangle. Pythagorean theorem only works for right triangles. Now, we did some problems in an earlier video where I said it's a right triangle. So you knew Pythagorean was going to work, and you just used the formula. But in this, I want to talk about the converse, which is saying if you had something like this, how could you use Pythagorean theorem to show that this is a right triangle? And basically, it just entails saying, is this statement, Pythagorean theorem, is it true or false? And if it's true, we have a right triangle. And if it's false, we don't have a right triangle. And here's what I mean by that. If you were to take the two legs, 5 and 12, again, the two smaller sides in this case, and you were to square those two, so 5 squared and 12 squared, and add them together. Let's just do that. 25 plus 144 is equal to 169. If you took the square root of 169, you would get 13. So the converse shows this is indeed a right triangle because Pythagorean theorem held true. Squaring these two and adding them together resulted in the square of this side. So we are able to say it is a right triangle. Pythagorean theorem will always hold true as long as we have right triangles. Let's do another example. Let's say we said this was 17. So we began by saying, well, if I take 8 and I square it, and I take 14 and I square it, and I add those two together, so 64 and 196 is 260. If I take the square root of 260, I do not get 17. So this is not a right triangle because Pythagorean theorem does not hold true. So really it just becomes, does it work or not? Let's do one last example. So take the two smaller sides and square them. Again, I'm not saying they're legs yet because we don't know if it's a right triangle or not. So 36 and 100 is 136. If I take the square root of 136, I do not get 15. So not a right triangle. If this video helped you, please like and subscribe for more math content.